Hey people. All right, this is the fifth reaction. Even though it says number 4 here, but it's because this is in a different order. So the fifth reaction is the double displacement reaction. This reaction has this general formula right here. Okay, so let's take a look at this. So what it looks like here is that in the reactants, you have the switching of W and Y. What am I talking about? The switching of W and Y. Okay, now last time we saw that when Y got displaced, Y was all alone. Man, how sad was that? But not this time. No. Okay, W is going to displace Y. But instead of Y being all alone, I went on to hook up with X. So it's sort of like the metal switched partners. Sort of like a little dance, W and X were dancing, and then Y and Z were dancing, and then for some reason they decided to switch. Wow, how cool is that? So as a result, you get WZ and YX. Okay, just like last time, the metal will displace the metal, or you can say that the non-metal displaces the non-metal. But of course, in no circumstances where W is gonna displace Z, meaning that metal will not displace a non-metal, or else it's going to be weird where you're going to have two metals and two non-metals, being part of a product. I don't think that exists. Okay, that would be extremely weird to see. So remember, just like single displacement, metal displaces metal, in a double displacement reaction. Now the question is this though, this is the hard part. Do all double displacement happen? We saw with single displacement the other day that no, not all single displacement can occur. No. Okay, it can only occur when, the one that is doing the displacing has a higher activity series. The one that's being displaced is lower in the activity series. That's when a single displacement will happen. Well, what about double displacement? One double displacement, you're not going to be looking at activity series. That would be ridiculous if you think about it, because you don't have somebody, you don't have an element displacing another element. You do, but in both cases, you're forming compound. You're not leaching anything out. So activity series will not be a good idea. Okay? But instead, there are, of course, something else that determines if a double displacement reaction will happen. And these are 3. So let's write this down. There's 3 scenarios, okay, where double displacement reaction will happen. So make sure you write this down. Okay? Number 1, this is an easy one because this one you can actually see it. You can actually see this. It's called precipitate. Precipitate formation. Now, what is that? The last time somebody talked to me about precipitate or precipitation, it means raining, right? But no, I'm not talking about no rain. I'm talking about precipitate. Solid formation. When you add 2 solutions together, which are both liquids, an aqueous form, and a solid forms, that's called a precipitate. Okay? I'm sure you've seen this before, where you're mixing 2 solutions and they're both clear. And then for some reason, when you mix the 2 together, the mixture ends up being cloudy. And if you let this mixture settle for a couple of hours, you see solid being formed at the bottom. Due to gravity, due to density. So that's precipitate formation. And now, this is the tricky part. How do I know a precipitate has formed in a reaction? Now that's something that you need to pay very close attention to, and I'm going to introduce you to something called solubility table. Okay, because this will determine if two things were to bond together, will it dissolve in water? So cool, eh? All right. Of course, there are three cases, so that's one case. The second case is gas formation. This one is hard to determine on paper, but if you were to do this experimentally, hey, that's pretty easy to see. You know, I see bubbles, man, bubbles. That means gas has been made. So that means this reaction is possible. And thirdly, water. Okay, if the product is water, that means this reaction have proceed. Okay, and we'll see that, and it actually has a special name. Okay, it's a part of a double displacement reaction family, but then it is given a special name because it's that special, because water is created. And we'll see an example of that. So three ways, okay, well, not 3 ways, but 3 scenarios, okay, where a double displacement reaction will occur is when a precipitate is formed, gases are formed, and water is formed. So let's see. Let's take a look at the first reaction. Let's see if any of these 3 criteria are hit, because if none of these 3, this reaction should be no reaction. So let's take a look at the first reaction. What we have here is potassium iodide. And what we have here is lead nitrate. Okay? I can tell you right now, both of these are soluble in water. What that means is that it can be dissolved in water. So if you take some Ki crystal, you put it in water, you stir it with a lot of force, this will dissolve. It becomes a solution. Same with lead nitrate. You put this in water and you stir it, it will dissolve and it becomes a solution. So now you have 2 solutions and you're gonna mix it together. By doing that, K will displace Pb to hook up with nitrate. Pb is not going to say, I'm going to be all alone now. No, I'm not. I'm going to come and I'm going to hook up with what you used to hook up with, iodine. Iodine. Okay? So I become lead iodide. And potassium, say now I become potassium nitrate. And that's exactly what you get. Right here. Right there. The switching of partners. You guys like that, right? So, as a result, okay, you have this and that. Remember, cross rule applies. That's why we have PBI2 and not just PBI. Okay, because in this case, this PB is a plus 2 PB. So charge remain consistent. Now, we've seen something like this before. Okay, where when a reaction occurs, the charge remains the same. So since this PB is a plus 2 PB, after doing the decross, this PB will remain plus 2 in the product size. So that's, see, it's plus 2. Okay. Anyway, now this is the time we need to check. Precipitate. Okay. If one of these is a precipitate, that means reaction will occur. Now, there's something that I'm going to stress upon, which I never actually stressed upon, is putting states into these chemical equation. Okay? Since Ki is a soluble solution, we will give it a state called AQ. This stands for aqueous. Okay? This stands for aqueous, meaning that Ki is in the form where it is dissolved in water and not its crystalline form. Same with lead nitrate. This is an aqueous form. right? They can't be in solid form. Because if you think about it, if this was in solid form, this is in solid form, how are they going to react? You're going to bang these solids together? Huh? You're going to bang these solids together? Hopefully if you bang them hard enough, they will turn to PbI2 and KNO3? No, that's not going to happen. You have to dissolve the solid into an aqueous first. You have to dissolve this solid into an aqueous first before they can react. That's something you need to know. Okay? Because these guys need to be in their ions before they can switch partners. Now, this will be talked about in more detail later on in topic 1. Right? So, no banging of solids, please. Now, remember what I just said a minute ago. If any one of these product is a precipitate, then the reaction is set to proceed. Now, how are we going to check? Well, what I've given you is this table right here. This is called the solubility table. This will tell you if something is dissolvable in water or not. Okay? So let me show you how to read this very quickly. This is arranged, of course, in anion. I have the anion nitrate. Okay, nitrate will form soluble compound, which means stuff that can dissolve in water. So maybe I should write this down. Dissolvable in water. Okay, dissolvable in water, that's soluble. So nitrate, if it hooks up with anything, is dissolved in water. So what that means is that anything that has nitrate in it can be dissolved in water, like sodium nitrate, lead nitrate, gold nitrate, potassium nitrate, aluminum nitrate. Any nitrate, you put it in water, it will dissolve. Which means it will form insoluble product with nothing. There is no nitrates in this world that is not dissolvable. Now, that's not entirely true. There's something called solubility later on that, the HL student will learn. Sorry, SL. I will teach you that later on. But then, of course, it's not required for you to know. But for the HL folks out there, there's something called solubility constant that you will learn later, where even though it says right here that everything is dissolvable in water, but there is a point when it won't. Jeez, man, I'm getting headache just thinking about it. Hey, but in the meantime, right now, all we're trying to do is to see if a double displacement will occur. So this table will do for now, HL kids. All right, let's take a look at this one though. Acetate. Okay, it says acetate will form soluble compound with most cation. Most. Like sodium acetate is dissolvable in water. Potassium acetate will be dissolvable in water. Calcium acetate will be dissolvable in water. Iron acetate is dissolvable in water. Except silver. So if you have something like silver acetate, that's not dissolvable in water. This, if or when made in a reaction, is a precipitate. It won't be AQ. No. It will be S, which stands for solids, and not some other S word that you're thinking about. All right? So that's how you read these. Let me do one more. Okay, let me just give you one more scenario. We have these anion, chloride, bromide, iodide, fluoride should be in here too. Okay? Again, these will form soluble compound with most things. Most things. Sodium, potassium, calcium, magnesium, iron, copper. Okay, copper bromide, soluble or not? Soluble, of course. Okay, iron bromide, soluble. Nickel iodide, soluble. When will it not be soluble? Well, when the cation are these guys. Silver bromide, not soluble. Okay. Lead iodide, not soluble. Okay. Lead bromide, not soluble. But mind you, it is very, very specific. Notice that when I use lead, I use the +2 lead and not the +4 lead, because if it was +4 lead, this is actually soluble. Huh. There's a difference. There is a difference. Okay? So that's how you use the solubility table. For now, to determine if something will form a precipitate or not. So let's go back right here and let's check these guys out. Let's check this guy out, check this guy out, because all we need is one of them to be insoluble for this reaction to occur. So let's check out PBI2. Let's check this guy out. Oh, look. All we have to do is go to the anion, I, okay, and we can see that it forms soluble compound with most, except for these four. Oh, lead 2 plus is one of them. Remember we mentioned here PBI2 is insoluble, so therefore, the state of PBI2 is going to be solid. This is a precipitate. Okay, that is a precipitate. Now, you can stop right here. You don't really need to check out this guy because it only takes one precipitate for this reaction to proceed. So we're done. But just for the sake of checking, because you like to check, what we have here is potassium nitrate. So you go to nitrate and you say, oh, that's pretty obvious. No such nitrate will form something insoluble. So therefore, nitrate will always be AQ. Okay? When I see you guys do these chemical reaction and predicting products, I do want to see states. I do want to see these AQ, S, and whatever that you'll see moving forward. Okay, so that's how you use the precipitate solubility table. Okay, there I have a worksheet right here for you. Okay, that you will need to do for homework tonight. So, let's do question 1 together. 1A, I'm not going to do the whole one. Come on, you guys do it. It says, pick the soluble salt. Okay, so out of these 4, which one is soluble? Okay, just really looking at the solubility table, right? AgCl, is AgCl soluble? Well, let's take a look. Cl is right here. Is Ag? Well, it will be soluble with most things except, Ag is insoluble. So AgCl is insoluble. So I am not going to pick up this one. This one will not be picked out because I'm looking for soluble salt, not insoluble salt. What about AgCO3? Well, let's take a look. Go to CO3. CO3 is right here. Okay, it says it will be soluble with ammonium, anything that is in group 1, except for lithium. Well, I have silver. Well, is silver ammonium? No. Sorry, no. Is silver group 1? No. Then it's probably here. This guy do not deserve to be circled neither. You can automatically circle this. You know that's soluble. Come on. Remember, everything is soluble when it comes to nitrate. What about silver sulfide? Does this deserve to be circled? So let's take a look at sulfide then. Sulfide, right here. Okay, what is sulfide hooked up with? Silver. Okay, ammonium is not silver. Group 1 doesn't have silver in it. Group 2 doesn't have silver in it, so most likely is most other cation in this case, and that's where silver is. You don't deserve to be circled. So the only one that is soluble on this list is silver nitrate. I know, this seems like a lot of work. It is a lot of work. But I need you to get really good at this. So make sure you practice. Make sure you show me that you can do this worksheet. Okay? At the bottom here, this is where the good stuff comes. Okay? So what you're doing do here in question 7 is that you're going to react these two guys. Nickel 2 bromide and potassium carbonate. You're going to react these two and you're going to determine if a precipitate will form. So nickel here will displace potassium. And potassium will come back and hook up with bromine. Okay? Check to see if nickel 2 carbonate or potassium bromide are precipitate. So I'm sure you guys can do this on your own with ease. Let me make some tears. Anyway, okay, that's one example. The second example, let's take a look at this example. HCl, we know it's called hydrochloric acid, especially when this is no longer a gas, but it's dissolved. Okay? When it comes to a double displacement reaction, you know for a fact that these things are dissolved in water. So this is hydrochloric acid and not just hydrogen chloride. Same with sodium hydroxide. This has to be dissolved in water. This is a base. Hydroxide, bonded with sodium, is soluble. Now, in this case, what you have here is a double displacement between H and Na to give you NaCl and HOH, which is H2O. The question is, will this reaction proceed? Now, if you check precipitate, you'll notice that this is an AQ. This is the killer because you won't be able to find it here because there's no oxygen anion. At the same time, this is water. Come on. Will this reaction proceed? Of course it will because it met this criteria. Water formation. Okay? When water is one of the products, you know for a fact that this reaction will occur. This is going to be a liquid. Okay? Now, as I said, this is one of those double displacement that deserve a special name because HCl is an acid. NaOH is a base. So instead of calling it a double displacement, when you're reacting an acid to a base, most people don't call it a double displacement. Most people call this neutralization. So whenever you see an acid and a base reacting, call it neutralization because that is more of a proper term of what this reaction is. But it is part of a double displacement family though. Right? Okay. Now, I'm sure you guys can do this on your own. I'm going to do maybe just the first one with you. And let me just, before I do those example, this one, as I said, is easy to determine on paper. It's easy to determine through experimentation. But through experimentation, if you were to react two things together, it's easy to see that, oh, I see bubbles. If I see bubble, that means gas has formed. But on paper, it is a little bit harder to determine. So let me give you some examples, okay, of gases, common gases, like H2S. That's a common gas. H2SO3 is a common gas. NH4OH is a common gas. And H2CO3 is also a common gas. So when you see these being made, you know for a fact that gas formation has occurred and the double displacement reaction will proceed. Just something to keep in mind, okay? Just something to keep in mind, and I'm sure these are things that you don't need to memorize, but just to let you know, it's not just precipitate and water that will cause a double displacement to happen, but gas formation as well. Easy to see, but on paper, hard to determine. So just look for these, okay? All right, let me do the first one with you, and then I think I'm going to leave the rest for you to do for homework. So what we have here is sodium carbonate reacting with copper 2 sulfate. So the idea here is that sodium will displace copper. Copper will come back and hook up with carbonate. So what you have is sodium sulfate. Remember, cross rule apply, and copper 2 carbonate. Why copper 2? Because this copper right here is a +2 copper, and it will remain +2 copper. It's not going to change the +1. Here it is. Okay? The lovely thing about this is it's already balanced. I love that. I love that because it's less work. Well, you're not done, because what you might want to do is you want to check to see if this reaction will happen. By doing that, you need to check if these guys, if any one of these guys, is a precipitate. So let's go. So sodium sulfate. So go to sulfate. Sulfate's right here. Is sodium, where's sodium? Is sodium one of these guys? No. No, is one of these guys. So therefore, this guy deserves an AQ state. I'll make sure you want to put AQ here too. Put AQ here too. Okay. What about this guy? What about this dude right here? Okay, copper 2 carbonate. So let's go. Let's look at carbonate. Carbonate's right here, right there. Okay, it is soluble if it's ammonium and anything that is group 1 except for Li. Oh, wait a minute here. Copper is not one of ya. Copper is one of ya. So therefore, this guy deserves an S because it is insoluble right there. Okay? Because of this, this reaction will proceed, and we're going to leave it like this. We won't say no reaction. Okay? So again, when the reaction is not any of these, that means no reaction, and you write no reaction, no need to balance and no reaction. Okay. So that's double displacement reaction in a whole. So make sure you understand how it works, okay, how metal displaces metal, and after you do the displacement, you need to check to see if it meets the 3 criteria, okay. The precipitate one is the most important. So learn how to use that solubility table by doing that worksheet. All right, I think that's it for me for today. And that pretty much concludes reaction. Now, that doesn't mean that we know all the reaction in this world. There's still a lot of other types of reaction that we haven't gone through. And we will go through as we move along in our journey of chemistry. All right, so what I want you to do for homework is to finish this sheet do these review questions. All you need to do here is to determine if these reactions are synthesis, decomposition, double displacement, single displacement, combustion. If it's a neutralization, make sure you say neutralization. I want you guys to say that. Anyway, lots of stuff to do. So let's move on. So in the next topic, we're going to start talking about quantities. Yeah, we're going to do some math now. There's going to be a lot of number crunchings from now on. Anyway, see you guys soon. Bye.